Let's take a look at sections 2.4 and 2.5. 2.4 is the section that introduces the base graphs, the key functions that you need to have memorized. You don't hear me say that word memorize often, but you absolutely must make sure you have these in your head. Okay, so you must be able to quickly recognize the graphs of the key functions. So if I give you the graphs, you have to be able to say, oh yeah, that's the graph of f of x equals whichever one it is. If I give you the function, you have to be able to very quickly graph it. Okay, so we're going to do several examples of this. I do want to show you the section in the book. So this is section 2.4, Library of Functions. They start with just going through some of the ones that they've talked about earlier, but if you'll turn over to page 82, starting down at the bottom with the constant function, these are the ones that they're calling the key functions, the base graphs that you have to memorize. I need you to know the constant function, the identity function, the square function, the cube function, square root function, cube root function, reciprocal function, absolute value function, and the greatest integer function. Okay? And now when I say no, what I mean is when I want you to recognize, if you see this equation, I want you to immediately be able to think that in your head. Okay? If you see this graph, I want you to immediately think the function in your head. You need to be able to tell me the domains, the range, any intercepts that they have. Okay? Notice that underneath each of the boxes throughout the section, it's all written out for you. It says what the domain, what the range, what the intercepts are. Okay, also here it tells you if it's an odd function. See, same thing here. So under the identity function it tells you. Okay. So like I said, you don't normally hear me say memorize, but this is one of those, yeah, you gotta memorize this. It's the trick to being able to be successful with the rest of the stuff that we do with functions. Being able to say, oh yeah, I know what f of x equals x squared looks like. It looks like a little U. It either opens up, it opens down, it might be fat, it might be skinny, but I know what it looks like. Okay, so what I want to do, I want to just show you a couple of things. Let's go to my PowerPoint. Okay, so you must memorize these. Okay, so if I gave you something like this and I said, hey, you got 30 seconds, can you match them up? Okay. Could you do it? All right, let's see. So the constant function is the one that goes straight across as a horizontal line. The identity function is the oblique line, the slanted line that goes through 0, 0. Square function, that's our good old quadratic. Cube function is the one that looks like an S that's stretched up and down. Square root function looks like half of a quadratic that's turned on its side. Reciprocal function, that's 15. That's the only one that's a fraction. You gotta look at it. Absolute value function looks like a V. It has a right angle in it. Okay, and cube root function looks like an S that's stretched out sideways. Okay, so I need you to be able to do it just that quickly in whatever order I give them to you. Okay, you're basically recognizing that the shape of the graph has something to do with the way the function is set up. Okay, all right, go the other way. So suppose I give you these and I say, hey, can you draw these? Now, when you're first learning these, now I don't expect you to be able to just look at the functions and just somehow, how just randomly memorize them, okay? When I say memorize them, think about how they create the function. All right, so for instance, x squared. Go back to your good old table of values, okay? -2, -1, 0, 1, 2. Okay? Literally plug them in. -2 quantity squared is 4. -1 quantity squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. That is what you're doing to get those points. Okay? So then if you plot them, it goes through 0, 0, 1, 1, 2, 4. -1, 1, -2, 4. That's where those points that are on those pictures in your book come from. Just a good old table of values. Okay. Pretty little curve, arrows on the ends. like so. All right, do it again with the 1 over x. Okay. You'll get to the point that you'll be able to do the table almost in your head. -2, -1, 0, 1, 2. All right, when x is -2, y is -1/2, because it's 1 over -2, which I would write as -1/2. If I plug in -1, I get -1. If I plug in 0, 1 over 0 is undefined, so what that says to me is it better not touch the y-axis, right? It cannot have a point with an x value of 0. Okay? When x is 1, 1 over 1 is 1. When x is 2, 1 over 2 is 1/2. Okay? All right, so at -2, I got -1/2. At -1, I got -1. At 1, I've got 1. At 2, I've got 1/2. You remember what it looks like from the other page? It runs up beside the y-axis but doesn't touch it. Runs out this way. Runs out this way. And runs down this way. Notice that it doesn't have any x-intercepts either. Because if you say 0 equals 1 over x, there is nothing you can do that's going to make that thing. You can't solve that, okay? Because you can't have the x equal 0. The 1's not going to turn into 0. There's no point on this graph that has an x value of 0 or a y value of 0, so no intercepts, okay? Okay, and let's try this other one. Let's do the cubed root of x. Okay, same old, I just want to make sure you got the hang of it. You are literally thinking, what would happen if I plotted points? So the cubed root of -2, oh boy, I don't know what that is. Let's just hold on a minute. So the cubed root of -1 is -1. Cubed root of 0 is 0. The cubed root of 1 is 1. And the cubed root of 2, oh, not sure what that is, right? Okay, so if we plot these, -1, -1, 1, 0, 0, 1, 1. Do you remember what this one looks like? This is the one that looks like an S that's stretched out sideways. Okay, you can take your calculator and you can get yourself an approximation for the cubed root of 2. Let's see. Do you know what it is? It's like a 1 1/4, a little bit more than that. But what that says to you is it's just going to get a little bit higher right there. In here, like that, okay? The next value that this actually works pretty on is 8. When x is 8, the cubed root of 8 is 2. So it's not going to get all the way up to a y value of 2 until it gets over here to 8. Okay? All right, so that's what I mean. Sketch and be able to do it really quick. Okay? Now, the other thing that is very important in this section is the idea of a piecewise function. It shows up a whole bunch in calculus, so you need to be really comfortable with these. They look weird when you look at them for the first time, but it's literally just a graph that's in pieces. And, you know, a lot of real-world examples, if you're going to model them, it's going to be a piecewise function. Okay, so the trick, so this one is just, hey, here's this function, and can you find f of -2, f of -1, f of 0? All right, so examine kind of what's going on with this function. It's basically f of x is going to be one of these 3 functions depending on the size of the x value. So if the x is littler than -1, we draw the -3x. If x happens to be -1, we draw 0. Okay? If x happens to be bigger than -1, we draw the 2x squared plus 1. Okay? So can you picture that? So it's just like 3 different pieces of the graph, and we'll draw one in just a second. But when it comes down to just literally finding the function values, just pay attention. If it says f of -2, well, x is -2. So which one of the conditions is it? Okay. It's this first one, right? Because x's have to be less than -1 for the first condition, and -2 is less than -1. So if I want to find f of -2, I plug -2 into that first part, and I get 6. If I want to do part B, f of -1, We'll have to look and see which condition that falls under. And it's this one. And it just flat out says if x is -1, f of x is 0. So I don't have to do anything. Okay. And the last one. All right, x is 0. So look at your conditions. See which condition this fits. 0 is bigger than -1, so it's this last condition. So that means I plug 0 into that last part of the equation, and I get +1. Okay. So if you're just plotting, if you're just trying to find function values, the main thing is you just have to look and see which condition that you're under to see which function you're plugging the values into. This is all one function, but it's different pieces at different places. Okay. All right, so let's look at this one. The main thing I'm after here is, can we draw this thing? Can we graph it? Okay. So easiest way to do this is with a pencil and an eraser. Okay. I'm going to start with the top one, right? F of x equals 2 minus x. And I'm not going to pay attention to the conditions just yet. I'm not going to pay attention to that square root of x. I'm just looking at that first little baby function. Okay. Now, do you recognize what this is? How about if I write it this way? Now, do you see it? It's a line, right? We did a lot of stuff with lines. Okay. So you should know your y-intercept. You should know your slope. So the y-intercept is 2. Slope is -1. So I can plot my y-intercept at 2. And then the slope of -1 means go down 1 over 1. Down 1 over 1. Okay. And I can keep plotting points. And I can sketch that in. Like so. All right. Now, look at your condition. Only draw that between -3 and 1. So I get my eraser. I go up here. Here's where x, oops, I didn't even draw it far enough. Hold on a minute. I'm going to erase all my points. There we go. Okay, so I get my eraser, and it's going to erase my whole line again. Watch it. But anyway, all right, so I'm only supposed to draw this between -3 and 1. So I take my eraser, and anything that is to the left of -3 gets erased. Okay? So all that gets erased. And anything that's to the right of 1 gets erased. And then that would just leave that piece right there. So between -3 and 1, pay attention. X is bigger than or equal to -3, so there is a point with a y value, excuse me, with an x value of -3. But see how at 1, it doesn't have the or equal to part? I need to be really careful and go over here. And at that point, I need to make sure that's an open circle. Okay? There is not an actual point at that 1, 1 spot. Okay? Because I'm only supposed to draw it for x is less than 1. Okay? All right, I'm going to switch colors. All right, so f of x equals the square root of x. Okay? Now, do you remember what that one looks like? Goes through 0, 0, 1, 1, 2, 3, something, 4, 2. There we go. And it looks like this. Okay. Now, same deal. Going to erase. It says only draw that for the x's that are bigger than 1. Okay. So I'm going to erase this. And all right, get the blue part back. Notice that at 1, it is also greater than. So there is not a closed point there. Okay. Now my blue line, with all the times I've redrawn it, it's not as straight as it should be. That should be a pretty straight line. Okay, the red line's slightly curved. Okay. But that's what a piecewise function looks like. Okay, easiest thing to do is to just draw the pieces and then erase the parts that are outside the restrictions. So, you want to try another one? How about this one? Okay, could you do that one? Right. Let's try again. First part, f of x equals 2x plus 5. Okay, so it's a straight line. Y-intercept is positive 5. Slope is 2, so up 2 over 1, or down 2 back 1. All right. Now, again, I'm going to draw this one between -3 and 0. So, okay, cool. And at the endpoint at -3, a closed circle's cool, but at 0, that's supposed to be an open circle. Trying to save myself the trouble of having to erase, but so much. All right, so is that right? So it's a line. Y-intercept of 5, slope of 2, drawn between -3 and 0 as my x values. Closed dot at -3, open circle at 0, 5. Okay. All right, go to the next one. F of x equals -3 if x is 0. So if I were going to sketch in f of x equals -3, well, that's this horizontal line. Okay. But I'm only supposed to draw it when x is 0. So do you see that that gives us really just that one baby point right there? Okay. And for the x is bigger than 0, f of x equals -5x. So that's a line. Again, y-intercept of 0. Slope of -5, so down 5 over 1. Oh, that thing's steep. And it's going to go like this. Well, oops. Wait a minute, where did that go? I moved my point. There you go. Back to my green. All right, so that just greater than part means this needs to be an open circle. And I am trying to draw this straight. It's not cooperating with me, and it keeps on going. Okay, so that's what this one looks like. Okay, so you could tell the domain. You could say which x values are used to draw the picture. You could tell the range. There's the picture. You could tell what intercepts you have. Is it continuous? No way. Okay, continuous, the idea is that you can trace it from left to right without picking your pencil up. This thing's in too many pieces. Okay, but that's the idea of a piecewise function. Okay, please make sure you take time with it. It does show up quite a bit as you go on into calculus, so pay attention to that one. Okay, how about if I give you the picture, the graph of a function, and say, hey, can you draw the equation? Can you write the equation? Okay. Start with what you know it's going to look like. It's going to be in pieces, so I'll open my brace so I'll have some space. I can see that this part is drawn between an x value of 0 and an x value of 2. And there's a point with an x value of 2, so that should be equal to, that should be less than. And I can see that this piece is drawn between -1 and 0. Oops. And there's definite points with an x value of -1 and a point with the x value of 0. So those are both or less than or equal to. All right, so if I got my intervals right, so for the part on the left, it goes from -1 to 0. And for the part on the right, it goes from 0 to 2. Okay, so what's the equation of those two pieces? This is a straight line, right? With a y value of 1. So the equation of that line is just y equals 1. Okay? Or f of x equals 1. Okay? So for any x's between 0 and 2, the y value is 1. For this piece over here, do you recognize it? If you need to sketch it out further, you surely can. Okay. Hopefully you're going to recognize that that's the identity function, okay, that f of x equals x. If you don't see that, you can see that it's a line with a y-intercept of 0 and a slope of up 1 over 1 and a slope of 1. And you can figure it out, but hopefully you're going to recognize it. So I need you to be able to go both ways. Okay, now in 2.5, I basically went in and I pulled the summary of all the stuff that can happen. Definitely take a look in the book, go through each of the pieces, but for what I want to do here and go through some examples with you, I'm going to use this blue box. Okay, so you're going to have your functions. Okay, you've got your base graphs that you're going to have memorized, or we're going to give you a picture, or we're going to give you some function, and then we're going to start doing what we call transformations. Okay, we're going to shift it left, right, up, down. We might make it fatter, we might make it skinnier. All these different things. And what's really cool is if you understand the functions and you can look at it and see where numbers are added, subtracted, and multiplied, then you can tell what happens to the base graph of the function. You don't need a graphing calculator. You can sketch it quicker than you can ever put it in a calculator. Okay, so for instance, let's look here. So look right there. Oops. All right. So for the vertical shifts, so if I've got some graph, right, maybe it's a graph of x squared, and I want you to move it up or down, what I'm going to do is I'm going to add or subtract a number out on the end of the function. Okay? If I want you to move it left or right, I'm going to add or subtract a number inside the operation. So inside the square, underneath the square root, inside the cube, inside the absolute value. So by adding or subtracting numbers in specific places and recognizing where those are, I can tell exactly which way I want to move the graph. So if it's out on the end and it says plus, I go up. If it's out on the end and it says minus, I go down. If it's inside the operation, it's backwards. If it says plus a number, I go left. If it says minus a number, I go right. Okay. So that's up, down, left, right, okay? Now, if I want to make it fatter or skinnier, there's two ways I can do it, okay? I can do it in terms of the y's, like stretching it up and down, or I can stretch it out left and right. Okay? So if I put the number out in the very front of the function, it's a compression on y. And basically what the little baby a does is it multiplies all of the y values by whatever a is. Okay? So you think about it as, you know, like the graph of x squared, stretching it way up high or squishing it down low. If I want to do in and out on the x-axis, I'm going to put the coefficient inside with the little baby x. Now, just like up here, how with the x and y, how with the horizontal and vertical shifts, vertical was just like you thought you would think it would be. The horizontal shifts were backwards. With the compressing and stretching, it kind of does the same thing. If the a is out front, then it's a compression or a stretch on y, and I multiply the y values by whatever that a value is. If it's inside, I multiply the x values by 1 over a. Okay, so the reciprocal of a. Or if it makes it easier, think about dividing by a. Since they multiplied by a, we do the opposite, we divide by a. Okay, so, and again, they watch their words. They use the word stretch and compress. Don't let that bug you. But it's just basically making it fatter or skinnier vertically or fatter or skinnier horizontally. Okay. I can also flip the graphs. If I want to flip it over the x-axis, I put a minus sign, a negative out in front of the whole function. I negate the whole function. If I want to flip it over the y-axis, I put the negative symbol inside the operation in front of the x. Okay. So again, this is kind of one of those memorized things, because if you can understand what all of these different operations do in terms of the graph, it saves you so much time. You'll be able to just look at something and recognize what's going on. So let's look here. So let's talk about the graph of x cubed. And all they want us to do is write the function whose graph is the graph of x cubed, but suppose I want to shift it to the left 4 units. Okay, so my graph of x cubed, do you remember? Goes through 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. All right, so I'm going to go with just these little points because my graph is too small. All right, so it looks like an S stretched that way. Okay, I'm going to get this pretty. Like that. Okay. So if I want to shift that graph to the left 4 units, I can literally take each of these points and go 1, 2, 3, 4 and redraw it. 1, 2, 3, 4, redraw it. 1, 2, 3, 4, redraw it. And my new graph looks like this. Okay? That's what it means. It's shifted to the left 4 units. Okay? Now what does my equation look like? Okay. How do you say move to the left? Okay, that means you're going to add 4 inside the operation. Okay, so inside the cube. So shifts left and right have to happen inside the operation, and it's the opposite of what you think. If it says left 4, you say plus 4. Okay, what about if I want to do it and I want to shift it down 4 units? So my original graph's the black one. If I want to go down 4 units, I literally pick up my points and I go down. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I redraw the graph. Okay. What does it do to my equation? Okay. Shifts up and down are done on the outside of the operation. And it's exactly what you'd think. If you want to go down 4, sorry. You want to go down 4, you write minus 4. Now, suppose you want to flip it around the x-axis. Okay, so if you want to flip it around the x-axis, that's when you put the negative sign inside the operation with the x. Okay. Remember, that's going to reflect it across the excuse me, if we're going to reflect it across the x-axis, I just did that backwards. Oh my goodness. Erase, erase. Oh. If I want to reflect it across the y, around the x-axis, it means I'm going to flip it over this line right here. Okay? So that means I'm going to switch the signs on all of my y's, so that means the negative sign has to go out in the front. Sorry about that. Said it exactly backwards from what I was thinking. All right, so if it's reflected about the x-axis, all the y values switch signs. So the minus is outside the operation. If I were going to reflect it about the y-axis, that's this one, okay, where the minus sign's on the inside. Okay, what about if I want to horizontally stretch it by a factor of 4? So if I want to take the black graph and I want to stretch it horizontally, okay? So is that an operation that's inside or an operation that's outside? If it's going to be a horizontal anything, it's going to be inside the operation with the x. And if I want to stretch it by a factor of 4, that means I need to multiply by 1/4. Okay? All right, how does that sound? Take a minute and make sure you look at those, make sure they make sense. Okay. Let's practice sketching just a few more, okay? Now, do you remember the blue graph that we looked at the beginning? Okay, so whenever we're going to actually take a function and we are going to apply all of these transformations to it, we want to kind of be careful and think. I tend to do my reflections on the x and y axis first, then do any compressing and stretching, and then do my horizontal and vertical shifts. So kind of up this list. You don't have to do it in exactly that order. It just tends to help keep everything nice and straight. Okay, so let's go here. We're doing the graph here. Do you recognize your base graph for g of x? Okay. So it should be the absolute value of x. So 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Pretty straight lines. Like that. Okay? All right, so I've got several things to do. This multiplies my y values by 3. This moves it to the left 1. And this moves it down 3. I think I'm going to go at it in exactly that order. I'm going to tend to the 3 first in the very front. It multiplies the y values by 3. So if you literally think, take your points. We've got what? Negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Literally go in and multiply the y values by 3. So this becomes 6, this becomes 3, that stays 0, that's 3, that's 6. Okay. So the negative 2, 6 kind of goes off my picture, off my graph. Then negative 1, 3. Then 0, 0, 1, 3, and 2, 6. Okay, so this is getting really steep, like that. Okay. Then I'm supposed to take the red graph, and the plus 1 says I need to move it to the left 1. So take the red graph, take every single point on the red graph, and go to the left 1. And resketch it. I'm going to let those top points just go. I'm going to stick with my main 3 that are still in the graph. Okay. Then the green says take that function, the blue one, and move it down 3. So take the blue function, take every point on it, and go down 3. 1, 2, 3. 1, 2, 3. And so the green graph is your final answer. Okay, so notice how in the directions start with the graph of the basic function and show all stages. Well, that's pretty much what we did. We started with the black graph. We stretched it vertically. We moved it to the left 1. We moved it down 3. Okay, how about h of x? Want to try that one? All right. Now, I will tell you, it's a little bit easier if you look at it like this. Okay. All right, so what do you do with that one? Let's start and sketch the original base graph first. Do you remember this one? Okay. So it was the one that was in the pieces. It didn't hit either of the axes. You can do your table of values if you need to, if you don't remember yet. So let's see, negative 2, negative 1, 0, 1, 2. So when x is negative 2, we had negative 1/2. When x is negative 1, we had negative 1. When x is 0, it was undefined. When x is 1, we had 1. When x is 2, we had 1/2. So the base graph, remember, kind of looked like this. And then it went through 1, 1, and 2, 1/2, and again like that. Now this is just the base graph, okay? Now, from the base graph, I've got to deal with the 4, which that's a shift, that's on the outside, okay? If I had wanted it to be a vertical, excuse me, if I had wanted it to be a horizontal shift, it would have had to been inside there with the X, okay? But this is going to be a shift up, a stretch vertically. Okay, and then I've got to deal with this plus 2 out here. Okay, so the 4 is on the outside of the operation, so it is a stretch vertically. And what do? I multiply my y values by 4. So it's a good thing we wrote it down. Okay, so if I multiply my y values by 4, So negative 1/2 times 4 is what? Negative 2. Negative 1 times 4 is negative 4. 1 times 4 is 4. 1/2 times 4 is 2. Okay, so let's replot those points. So negative 2, negative 2, negative 1, negative 4. 0, 0 stays there. Or, excuse me, 0 still undefined, sorry. Then we've got 1, 4, and 2, 1/2, or 2, 2. Okay, so it's still kind of stretched, funny. And you know I'm doing the wrong color. I'm supposed to be doing, okay, wait a minute, hold on. Switch this right there. Hold on. I'm doing the 4. So it's supposed to be in blue. Okay. And then like that. All right. And then the +2. This is a shift up and down. We're supposed to go up 2. So take every single point that's on the graph and move it up 2. Okay. So this goes up to here. This goes up to here. This goes off my graph. This goes up to here. And let's see. So stretch. I'm trying to draw it real carefully here. Like that. And the x-axis, if we think about it going up to right there. So I'm trying to make sure that I draw it stretched out like it's supposed to. Like so. Now that's really messy. If you were doing this for a grade, you'd want to go back and clean this up a whole bunch. I'm trying to keep all of my steps in there for you so that you can see all the different colors. But the red is the final answer. So it's really stretched out, still running up and down beside the y-axis, still going to kind of run out at +2 and going both ways. Yeah, so the final answer is the red one, but if it wants you to show all the stages, then that starts with the black, then to the blue, then to the red. Okay. All right, let's see, let's go here. Suppose I tell you that 3, 6 is a point on the graph of y equals f of x. Okay, so which of the following points must be on the graph of y equals negative x? Huh. Excellent little test question. Look, it's multiple choice. Easy test question. Right? Can you understand what it's asking? So there's this function, and I'm not telling you what the function looks like. All I'm saying is that somewhere, that is so not straight, that somewhere on that graph, okay, that's just too crooked. Can't take it. All right, here. This is the point 3, 6. And it's on the graph of some function, and we don't have a clue what it's doing, but it's just on it's on the graph of a function. If I said to you, graph y equals f of negative x, what does the negative x, what's that negative do? Which way does it flip it? Okay, does it flip it over the x-axis or over the y-axis? Okay. It's on the inside of the operation. Okay, so that's the left, right, so it's a shift over the y-axis. So if I took this point 3, 6 and I flipped it over the y-axis over here, what changes? Right? It should just change the sign of the x value, right? Okay. It multiplies the x value by -1. Just flipped it right over the y-axis. And so what's that, d? All right, try another. Suppose I tell you that this point 4, 2 is sitting on the graph of some function. What happens to that point? Well, every point on the function, but specifically that point, if I say graph y equals f of 2x. What does that 2 in front of the x do? Okay. Again, it's on the inside of the operation, so it's going to pull it or stretch it left or right. Okay, it's compression or a stretch on x. Remember, if it says times 2, that's the same thing as multiplying by its reciprocal to change the values on the function. So if we've got the point 4, 2, it multiplies all of the x values by 1/2. So it becomes the point 4 times 1/2 is 2. It becomes the point 4. It becomes the point 2, 2. It's exactly like we were doing here. But here we were moving a whole bunch of points. Like for instance, if I wanted to take the black graph over here and move it into, to make the red one, I moved the 3 different points. And then I moved 3 points to make the blue one and 3 points to make the green one. Well, on these problems, you only have 1 point to deal with. Okay, you're not, because you don't know what the rest of the function is. You just know it's a function and you know you've got this point and you're supposed to move it. Okay, so you have to understand what it means to you that they go in and put that 2 in front of the x. Okay. All right, let's try one more. So suppose there's this function, and it has x-intercepts of -8 and 1. Okay, and I'm going to actually write it as points. Okay, so those are my x-intercepts. And I have absolutely no idea about what's going on with the rest of it, but those are my 2 points. Okay, so what happens in A? Suppose I say graph y equals f of x plus 4. What does the plus 4 do? Should say move it left 4. It's inside the operation. Okay, so take both of those 2 points. If you pick up this point and you move it to the left 4, where does it end up? If you take this point and you move it to the left 4, where does it end up? Okay. So -8 minus 4 is -12. And 1 minus 4 is -3. So if I pick those points up and I move them to the left 4, they're going to end up at -12, 0 and -3, 0. All right, what about if I say f of x minus 3? That means go right 3. So go down to each of the points. Literally pick them up and move them to the right 3. If you move -8, 0 to the right 3, -8 plus 3 is -5. And 1 plus 3 is 4. Doesn't affect the x because all I was doing is moving it left and right. Okay. What about if I said I want to graph y equals 2f of x? What does the 2 out in front do? Multiplies the y values by 2, right? So now if we go down and look at our points, well, our 2 y values are what? 0 and 0. If you multiply them by 2, you still get 0. So this doesn't change my x-intercepts at all. It affects the y values. It multiplies the y values by 2. My y values are 0. 2 times 0 stays 0. These are the same as the original function. Okay? And, all right, let's go one more. Y equals f of -x. So now it's inside the operation. It's a reflection across the y-axis. It flips the thing, literally twirls it on the y-axis. Changes the sign on all of your x values. The positive x's become negative. The negative x's become positive. So the -8, 0 becomes +8, 0. And the +1, 0 becomes -1, 0. So see how we do all this in our head? The calculator wouldn't help us with this. This is just understanding what all the little rules mean, where you add, subtract, multiply numbers, what it does to the graph of a function. Okay. Now, I did want to point out to you, there are a couple of these in the book, and I do not want them to confuse you. Pay very close attention to the directions. See how it says, find the function that is finally graphed after each of the following transformation is applied to the graph of that in the order stated. Okay, so whenever we're doing graphs like this, we do it really carefully. We tend to our stretches, our compressions, our flips, then our up, down, left, right stuff. But whenever they give us one like this, they are saying, hey, take this graph and literally do exactly what I'm telling you to do for it. Okay, so we're going to start with the graph of y equals square root of x. 0, 0, 1, 1, square root of 2, square root of 3, square root of 4 is 2. So that's my base graph right there. Okay, literally take that graph and move it up 2 is what number 1 says. So up 2, up 2, up 2, like that. Now, take the red graph and flip it across the y-axis. Okay, so this point comes here, that point stays there, this point becomes negative 4, 4, like that. Okay, and then that one gets picked up and moved left 3. So like that. Okay. So now, if you do all that stuff in the order they tell you to do it, you end up with the green graph. Well, they want you to tell them what the equation of that graph is. Okay. So now think about it. Suppose you don't see the red, the blue, the black. Okay. You've got y equals, you know it's a square root function. Let's see. The point that was at 0, 0 is now sitting right here. So it went 1, 2, 3 to the left. So how do you say 3 to the left? Okay, that's inside here. How do you say up 2? That's out here. And now how about that flippy thing? Okay, because now it was supposed to look like the original black graph went this way. So now we want it to go flipped across the y-axis. So that means I need to go inside the operation, and I need to put a minus sign in there to tell me that I want to flip that thing. And I want to be real careful. Put some parentheses to make sure it's really clear what I'm saying. Okay, this minus says I flipped it over the y-axis. This says I moved it to the, which way? Now, which way did I write that? I'm supposed to be going to the 1, 2, 3 to the left 3. That was supposed to be a plus 3 to start with, wasn't it? Oh, see, now I just made that all confusing. Hold on a minute. Let's write it again. Okay. So I want to get the green graph. It went 1, 2, 3 to the left. How do I say 3 to the left? I write plus 3 because I went backwards. Okay? It went up 2, so plus 2 on the outside. Then I need to think about how do I tell it to reflect it across the x-axis? Okay, so how did I do that? There was a minus sign in the front. Okay, sorry about that. Didn't mean to write that symbol wrong in front of the 3. Okay, hope this was helpful.